Hello everyone, I am Team Mubina from AAA section and my roll number is 234G1A0262. Today I am going to explain my topic name is Taylor's method. Let us consider dy by dx equals to f of x comma y with an initial boundary condition y of x naught equals to y naught of the function y equals to f of x of Taylor series can be written as f of b equals to f of a plus b minus a by 1 factorial f dash of a plus b minus 2 whole square by 2 factorial f double dash of a plus b minus a cube by 3 factorial f triple dash of a plus. Suppose at x equals to x naught or x minus x naught. Y equals to f of x equals to f of x naught plus x minus x naught by 1 factorial f dash of x plus x minus x naught by whole square by 2 factorial f double dash x naught plus x minus x naught by 3 factorial f triple dash of x naught plus given that y of x naught equals to y naught equals to f of x naught with respect to x minus x naught equals to h. X equals to x naught plus h equals to x1. Y equals to f of x1 equals to y1 equals to y of x1 equals to y naught plus h by 1 factorial y naught dash plus h square by 2 factorial y naught double dash plus h3 by 3 factorial y naught triple dash. Similarly, x minus x1 equals to h, x equals to x1 plus h equals to x2, y2 equals to y of x2 equals to y1 plus h by 1 factorial y1 dash plus h square by 2 factorial y1 double dash plus h cube by 3 factorial y1 triple dash plus y3 equals to y of x3 equals to y2 plus h by 1 factorial y2 dash plus h square by 2 factorial y2 double dash plus h3 by 3 factorial y2 triple dash plus x minus x1 equals to h, x equals to x1 plus h equals to x2, y2 equals to y of x2 equals to y1 plus h by 1 factorial y1 dash plus h square by 2 factorial y1 double dash plus h cube by 3 factorial y1 triple dash plus y3 equals to y of x3 equals to y2 plus h by 1 factorial y2 dash plus h square by 2 factorial y2 double dash plus h3 by 3 factorial y2 triple dash plus. Example. Solve the differential equation dy by dx equals to x minus y square, comma y of 0 equals to 1 by using Taylor series method. Complete y of 0 comma 1 and y of 0 comma 2. Given function y dash equals to dy by dx equals to f of x comma y equals to x minus y square. Given boundary condition initial y of x naught equals to y of 0 gives rise to x naught equals to 0 comma y naught equals to 1 where h equals to x minus x naught equals to 0.1 minus 0 equals to 0.1. Similarly, x equals to x naught plus h equals to 0 plus 0.1 equals to 0.01 equals to h1 x1 from the Taylor series. Y of x1 equals to y equals to y of 0 comma 1 equals to y naught plus h by 1 factorial y naught dash plus h square by 2 factorial y naught double dash plus h cube by 3 factorial y naught triple dash plus. With respect to y dash equals to dy by dx equals to f of x comma y equals to x minus y square. Y naught dash equals to f of x naught comma y naught equals to x naught minus y naught square equals to 0 minus 1 equals to minus 1. Y dash equals to d square y by dx square equals to d by dx of dy by dx equals to d by dx of x minus y square equals to 1 minus 2y dy by dx equals to 1 minus 2yy. Y naught triple dash equals to 1 minus 2 y naught dash equals to 1 minus 2 of 1 of minus 1 equals to 1 plus 2 equals to 3. Y triple dash equals to d cube by y by dx cube equals to d by dx d square y by dx square equals to d by dx of 1 minus 2 y dash. 0 minus 2 of y double dash plus y dash dot y double dash. Y triple dash equals to minus 2 of y double dash plus y1 y of whole square y naught triple dash equals to minus 2 of y naught to y naught triple dash plus y naught whole square equals to minus 2 of 1 of 3 of plus minus 1 whole square equals to, and final answer is minus 8. Y1 equals to y of x1 equals to y of 0.1 equals to 1 plus 0.1 minus 1 plus 0.1 whole square by 2 factorial of 3 plus 0.1 whole square by 6 of minus 8 equals to 0.91. This is the second method. Similarly, y2 equals to y of x2 equals to y1 plus h by 1 factorial y1 dash plus h2 by 2 factorial y1 double dash plus h3 by 3 factorial y1 triple dash. Y1 equals to y of x1 equals to y of 0.1 equals to 0.91. H equals to h minus x1. H equals to x minus x1 equals to 0.2 minus 0.1 equals to 0.1. X equals to x1 plus h equals to 0.1 plus 0.1 equals to 0.2x2. Y2 equals to y of 0.2 equals to 0.91 plus 0.1 by 1. Y1 dash plus 0.1 whole square by 2 factorial y1 double dash plus 0.1 cube by 3 6 factorial y1 triple dash. We know that y1 equals to dy by dx equals to f of x comma y equals to x minus y square. Y1 dash equals to y of x comma y equals to x1 minus y1 square equals to 0.1 minus 0.91 whole square equals to minus 0.7. Y double dash equals to 1 minus 2 y dash y1 triple dash equals to 1 minus 2 y1 dash equals to minus 2 0.91 of minus 0.71 equals to 2.292. Y triple dash equals to minus 2 y double dash plus y1 whole square. Y1 triple dash equals to minus 2 of y1 triple dash plus y1 dash whole square. Y1 triple dash equals to minus 5.17. Y2 equals to y of x2 equals to y 0.2 equals to 0.91 plus 0.1 of minus 0.71 plus 0.1 whole square by 2 factorial 2.19 plus 0.1 cube by 6 minus 5.17. Y2 equals to y of 0.2 equals to 0.84. Thank you, and signing off, Team Bina from Fertilization.